Hey everybody, it's Larry. Biweekly Contest 21, there are about 30 seconds left. Yeah, hope everyone enjoys it. Hit the like button, hit the subscribe button, leave some comments, questions, answers, whatever you like to leave. Uh, 15 seconds left. I'm in Luang Prabang. Hope I'm saying that okay in Laos. So we'll see how that goes. Hopefully I do pretty okay, but uh, just here to learn, I suppose, and then we'll see. Let's go. All right. All right. Q1, increasing, decreasing string. So I think this one is just simulation. And yeah, I mean, I think that, now that I could look, yeah, and I was reading the instructions very quickly or very thoroughly and deliberately. So just to make sure. Also, you could see, if you look at my face, my table is really tall. So like you're gonna see like only half my face, but that was my optimal coding angle because I'm like typing like this. So just to kind of give you a little heads up, but but I think there's just follow the instructions. I think this is what getting practice gets you, is that you're able to kind of get through this in a very slick, fast way. And that's more for computer programming versus interviewing. And what I did is I used the section of collections dot counter, though I kind of mentally changed that, but I'm not ready to use collections dot counter during a contest just because I'm always like, maybe I'm going to, mess something up, and that slowdown will cost me more than whatever time it saves me for now. That's something that I have to mentally, get to work on in the future, hopefully. But for now, and that's what practice gets you, is that trying to do things in a way that is that basically uh, doesn't yield itself to as many mistakes. So basically, you wanted to write things in a way that um, yeah, you just don't make mistakes or like it's harder to make mistakes. The edge cases are kind of embedded in how you code it and so forth. And for me, I just literally read the instruction in the other way, which is that go from A to Z and then Z from A and then go back and forth. Um, and and using a hash table slash counter to facilitate that. Um, and that's pretty much it. And there's some invariant there, but because the length of the string is only 500, I know that you only do the loop at most 500 times, which is assuming that all, both the same, or the entire string is the same character, I think. Um, so that's 500 times 26. That's good enough. So then I run. Looks okay. I put in the test because I'm trying to be careful, um, especially since I don't know, just still. I mean, I did very well last week, and that's not to brag, even though I did very well last week, I know that I'm still a little bit rusty. I haven't done these in a little bit, and probably just got more lucky last time. So yeah, so that's why I'm still trying to be deliberate. I'm like, okay, that looks good enough. I try to look at the input just to see if it matches. I'm like, okay, that looks good enough. Hit submit, and here we go. So I did that in 3 minutes, which I think is probably about 30 to 40 seconds too slow for me. It probably could have been even faster than that, but that's the amount of time I would expect. Q2, even counts. Wow. I had a lot of struggle with this one, and you kind of see throughout. I actually don't really know how much time I spent here well, we'll see. Um, but what I was thinking here is I was going for a couple of things in my mind. A lot of it was I was trying to get the two finger or the sliding window algorithm to work in my mind, and I keep on coming back to it even though I couldn't. Another one thing I was thinking of some sort of prefix sum where yeah, I was thinking of some prefix sum where okay, you have some index, and then you could look up another index in, like, given two indexes, you could see if they're um, a valid substring in all of one time, right? But that's still n squared, and n in this case is 10 to the fifth times 5, so that's too long. I was thinking about things around that, along those lines, and I do struggle and take quite a bit of time doing that. So I'm just really mentally thinking about it, and I couldn't figure it out between those two things. I think I start typing a little bit here and there, but I just couldn't get it out. Um, but yeah, so I'm gonna like yeah, and I type in here now, and then I'm like, the case that I really struggle with was trying to figure out like I was also thinking of maybe there's some kind of like overlapping segment type thing, like maybe there's some greedy thing that I can play along with. The thing is that given that n is 10 to the fifth, you know that it has to be linear. Well, okay, linear or n log n, but like linear-ish, right? And I was also, I think, from that trying to figure out like, is there a thing I could binary search on or something like that? Um, like given, an index or a character, like is there a thing we could binary search on? And it's not, and I couldn't find one, right? Because you could go from true to false to true to false and so forth, right? Alternating. So I was trying to bounce around those ideas, and that's kind of where I am at. Um, yeah, I'm going to skip ahead. Just follow the links below and get to the next question or whatever. Hmm. Okay, so Q3, I skipped ahead after spending about, seems like 5 or 6 minutes. I just couldn't figure it out. I think my mind was thinking about skipping ahead eventually, and I just kind of, I wouldn't say give up, but just want to come back to it and kind of maybe get some momentum going, and maybe in the back of my mind, I'll be thinking about it. This one I knew how to do immediately. Some of it's because um maybe a contest ago, or maybe two contests ago, there was something like very similar to this, and I did it in a very fancy way and got it right. But I also thought that there's a cleaner to understand way, and that's what I was trying to do here. which is like I was trying to go, okay, for each node, start the beginning of a zigzag path here, and then that's it, right? And that's n square. With a thing that I'll talk about when I get to it. But I think initially, I think I just read the number of nodes as 5,000 instead of 50,000. So in my mind, n square was, I think I just considered n square, and then I never stopped considering n square until I ran into issues because it's 50,000, not 5,000, as you can see. But yeah, right now I'm just writing the base cases. If the root is none, then we just return 0 because there's no zigzag path. Otherwise, we return, yeah, we return the max of, well, I was trying to think about different ways to do it. I was like, do I need 3 recursive functions or just 2? So I just want, okay, let's just start at the current node, or the left child and then the right child and so forth. Or just in this case, I just actually do recursive so that you basically, or this the idea behind this is to branch out and yeah, just start each node at least once, and each node costs O of n to calculate, so that's why it's n squared. But we'll see the fix later. Yeah, and here I already knew that I want to go like, okay, so the second parameter is just if the first node is going left or the first node is going right. So that's kind of how I did it, or like what I'm thinking here, and I type it out. I have some typos, but that's fine. I mean, or at least these are the ones that didn't cost me that much time. I think it was just that my mental state is in terms of getting this was still just on focusing on getting it right. But yeah, right now I'm just writing really dumb recursion. There is a little bit of an edge case, but it's fine. I was going to do just not left, which actually would have been better because this ends up being because I got the alternating wrong. Because once you go left, you're supposed to go right, but I think I just mentally didn't go, and also I didn't have a yeah. And here I'm just typing up more stuff, and yeah, forget that. I just have to kind of call the function in a good way. Sometimes I do the inner recursion stuff, but sometimes I don't. I don't know. But yeah, so that looks okay. But well, except for the last one where it should return 0 with one node. So I knew that there was some weird edge case. I mean, I kind of knew that as I was doing it, but I also know that yeah. So how did I end up taking on this one? End up taking, let's say, subtract 5 minutes. I took about 13 minutes on this one. A lot of this is just silliness, and I was like, okay, I could probably do this in a clever one-liner, but I was just like, okay, let's just type out the case where because you're counting the edges and not the nodes, so there's some like off by 1 potentials, and you could maybe change the base case to match that, but I wasn't confident in that part. And here, basically, I'm done. I think. Oh well, I got the wrong answer, so I knew that. I was like, wait, is this right? Nope. Okay, and I was like, okay, that looks good. I'm submitting, and I'm done, right? Nope, n square. I was like, wow, this judging is a little slow. I hope that it. Took a look at Q2, but didn't really. I can't focus like that. Some people can, but or like change my focus like that. I was like, oh, time limit. I'm like, oh, 50,000.
It's a little slow.
So of course n squared is not going to work at 50,000. It's like, duh. And I was like, okay. And I looked at all the functions. I was like, everything's cacheable. Let's just cache it. I was trying to do this LRU cache thing. So I was Googling LRU cache, I think, at this point. But hopefully next time I would, I'll be practiced enough that I don't need that. Well, I don't need to Google, because that would have been, let's see, this is about 15 minutes in. So if I had pressed the LRU cache thing, I literally spent 6 minutes trying to figure out how to cache. So that's kind of, well, 6 minutes is a lot of minutes to give away on a quick contest like this, but that's fine in the sense that, 6 minutes is a long time for one contest, but 6 minutes is not a long time if that means you're going to learn something that will improve how you code for the rest of your career. In my case, my competitive programming career, to be clear, because in my regular career, I imagine I imagine that I don't need to. I mean, I can look up on Google, and I don't have to save a couple of minutes. But so this was kind of painful, and I just couldn't figure, because some of this is Leetcode specific, to be honest. Because in not Leetcode, I would know what to do, because there is some magic about, like, it imports, I don't know, a good amount of libraries, but not some libraries. So I don't know how to handle that. Now I learned, so that's good too. But at the time, I was just like, because Leetcode does some magic, and I just try to put some cache here, and I try to implement it correctly. And there's always this like self dot stuff, which is always really annoying. But it is what it is. And that basically is my next couple of minutes, is typing up this cache. Like I said, I spent 5-6 minutes because I didn't know how to use LRU cache to build in one. So yeah, so I mean, it's a learning lesson, and I hope that's, if you're to take one thing away from it, then yeah, do it. I think in the past I have said that, like, it's usually not that bad, you just have to do it. But this one was a mess to do, so and definitely mixed. I mean, I think I still for dynamic programming I might still do it, but I think for tree type problems where you should cache, this just make it really easy, and it's something that you could say paid immediate dividends, in a sense that in the next part, and I missed some of these, in the next problem, the hard one, I used what I learned here immediately. So that was actually, at least I paid the price only once or whatever, and hopefully in the future I would also keep remembering how to do that. But yeah, and I'm just having issues with guiding, and I was like, oh, still time limit exceeded. Does that make sense? It shouldn't, but the reason is because I mean, you see, when you see how I fixed it, when you see how I fixed it, then I was like, there's not, if it cached, there's no, like, some of it is intuition, that if it caches correctly, that has to be true. Like, it's O of n, so it can't really be faster than O of n in general, right? I mean, like, if it gave me like memory limit exceeded or something, I'd be like, okay, I have to figure out another clever way, because that's the trade, memory for speed, and I messed that up, right? So I looked at everything, I'm like, now this looks okay, but it just happened. It turns out that the way that I did my recursion, because I used the kicker, or the starter, the kicker, for the dynamic or for the recursion, I created the cache every time here on line 30. So once I kind of noticed that, I was like, none of this makes sense. I was trying to maybe point out a cache. I was like, I mean, I did do that, and I created a very simple case. Yeah, I mean, overall, like I said, if you could finish a little bit outside top 100, I guess it seems like, on your really bad day, yeah, that's pretty good, I think. Here I was like, okay, maybe there's some weird stuff of oh, not weird. Here I was thinking like um, maybe there's some stuff of like, okay, if this gives me an answer, then if it gives me an answer bigger than 0, then it has to be a maximal answer because you can only be offset by like 1 or 2. Um, Someone like that. But I was like, okay, that is too tricky to maybe not now that I think about it. But at the time, my thinking, like when I'm coding this, I was like, is that right? Is that like because I'm still trying to figure out like, because you have to prove that correct. And it's actually not a difficult proof uh, uh, now that I'm here and I'm able to think about it in a clearer way. But at the time, I was like, okay, is that right? Um, because if you zigzag, there'll always be a pattern after 2, right? Or like you either start or you're in the middle of a pattern or something like that. So, so yeah, the same reason why you could do the caching really. And I just couldn't figure it out. I wasted a couple of minutes just looking at debugging this, and then eventually, yeah, I spotted line 30, and I was like, oh, because I'm kicking off, like I'm clearing the cache out on every recursion, therefore, uh, it doesn't actually cache. So that's why I was like, okay, what am I doing? How do I fix this? And I just, in the interest of time, or like solving it as soon as possible, I just wrote another wrote another wrote another recursive function, and I was trying to write something like, oh, if cache is not set or something like. I probably could have done that actually, but I just didn't want to deal with typos and stuff like that. I think now I know. Now that I'm calm, I know how to do it. It's just dot attr or something like that. Um, but yeah. So yeah, just a couple of silly mistakes, but all of them dealing with caching, which I'm, happy paid to kind of, well, not that happy, but happy enough paid to learn something. So yeah, what do you need to learn to? And I got accepted. I was really happy. Cache one, then I wouldn't have to deal with all this stuff. All right. Maximum sum BST and binary tree. So this one, because I just did, because I just did Q3, the last problem. I was like, this is very similar. And I was thinking about like, is there anything quadratic about this? And I was like, okay, like not really, right? Like everything you can cache and as long as you can define a binary search tree in terms of itself, then it becomes linear. Um, I mean, with some helper functions, which you can also cache, which is what I did. Uh, yeah, and then as soon as I'm just reading over the problem right now just to see if I think I was just trying to, I don't know, just trying to get a better sense of it. Oh yeah, and then I was like, okay, let me just look up LRU cache, and then that's it. I mean, I spent some time. I'm still just kind of. I think right now I was looking up my previous code that I've written because I just forget the um, exact way to do it for Leetcode specific because I think I've done it once. So I was trying to find that example, and that's what I was doing there. And then as soon as I did, I was like, okay, um, yeah, and I have that, and then that allows me to solve everything in linear time without LRU cache. But yeah, but right now I'm just writing pretty much everything, um, and this formula. I mean, this formulation is pretty straightforward. Basically, I'm doing the same as I did last time, kind of, which is for each node. Uh, See if it's a binary search tree. If it's a binary search tree, calculate the sum. That's it, and then just do some comparison to see if it's bigger than your current best and so forth. Uh, but yeah, yeah. And right now I'm just like, oh, usually I changed the way I wrote this so that like it uses a variable instead of returning the best value or something like that. So, which I don't know. I think it's the same maybe. Except this is not how you cacheable, so maybe I could have done that. But you only use each node once, so you don't need to cache this. But that's what I'm doing now. And then yeah, for each node, let's see if it's a binary search tree, and then I kind of write will help it. Yeah. But yeah, and right now, yeah, these are just base cases. I was just double checking on, you know, just checking on stuff. And I was like, okay, if so, one way about binary search tree is that it's a binary search tree if the left subtree is a binary search tree and the right subtree is the binary search tree, and then also the on your left the max node is smaller than your current node, and on your right, your min node is smaller than or bigger than your current node. Um, so yeah, but that's basically what I did. I was debating just caching it in a smarter way, to be honest, because sometimes I do this where on the BST, uh, like on the SBST, I would maybe do um, some kind of helper method to kind of help with this, and then store it on the node itself. But then I was like, okay, I really want to make up for some lost time here. So yeah. And I was just like, okay, look, getting the max and the min is going to be linear, but if we cache it, then it stops being linear. So then you could, it is almost essential like putting it on the node, and you could have, yeah, and you could do this in a different way, but that's the way I did it. Um, yeah, and then after that, I just do the score, also cacheable because it's just the sum of, or at least it's cacheable, especially if you write it recursively, which is really easy to do. And that's pretty much what I did. Yeah, that's pretty much Q4. And I'm spending 15 minutes here. Why do I still have 7 minutes of stuff? I have some. Oh yeah, that's right. So that's mostly right, except for my definition wasn't, or my if statement definition isn't clear enough that so yeah, you see how I fixed it, but basically I don't consider but to get max returns none if I think if the node is none or something like that. So that statement never be true. So I have to do this print statement debugging, but yeah. Um, I mean, yeah, I knew that that line was wrong, so now I'm just trying to think about like why that is. And I spent way too much time on this because I end up, well, I mean, I didn't realize. I think I should have. I just didn't. But I did end up printing them out to do it. Um, so that was kind of, now that I look at it, I spent about 15 minutes on this problem. Like a reasonable time is probably closer to 8 minutes because I think I got this really quickly. Um, like I spent 6 or 7 minutes just like doing this debug, which I probably could have gone directly, and I still didn't even see it now. Right? Like I'm still printing, so yeah. Eh, it is very painful to watch. uh, Hell is watching yourself making the mistakes that you've done again, right? That's what someone said. And it feels that way every time I record these. I'm like, Larry, what are you doing? But it is what it is. I mean, I think like, I mean, everyone, yeah, with reasonable fundamentals knows what a binary search tree is. So it's something that when I was coding this, I knew about this while I was coding it, but well, not while I was coding it, but I was thinking about a problem, and then I just forgot about it when I was typing it out exactly. So and even that is wrong. Lucky that I fixed that because I was like, oh wait, what about if the case is none? Because I didn't change that. Um, so yeah. So I got the right answers. I was like, okay, is that good enough? And then I just want to double check to see if I cached everything. And I was like, it looks as good as it's going to get. So I submit and stat phase, maximum recursion depth. So I was, yeah, getting a max recursion depth. Shouldn't have done it with recursion, I guess. So yeah, so I was just trying to figure out how to do. I think I am Googling at this point how to. I mean, so I know enough about Python to know that you can change it, but I don't know if it for Leetcode specifically. Uh, you know, I don't know like if that does anything or changes anything or especially. Um, but yeah, so that took so this one it seems like it ended up taking about 3 or 4 minutes, plus the penalty, which I mean it sucks, but you learn for next time. I think that this is acceptable for me. Like no way for me to learn. But I mean, no way for me to know beforehand, kind of maybe. But at this point, we'll see what it goes. Here I just changed it to. I guess I could just slightly want to. I didn't want to go too big. I just wanted to see if it works. And it still gave me that error. So I was like, yeah, okay, maybe that doesn't work. But and I was just like on a little bit of Hail Mary at this point, to be honest. I was like, okay, let's just change it to something big and then see what happens. Because eventually you run into like memory issues and stuff like that. And I was like, okay, well, I don't know if this big answer is correct, but what else have I got to lose? So I just submitted it, I think. And I was ready to like not get accepted on this one, to be honest. Okay. But yeah. Yeah, back to Q2. Yeah, this one was very hard, obviously, still for me. Let's see. Why do I struggle with this? But yeah, eventually, and I, even after the, it still takes me about 17 minutes after the first problem, or the last problem. So yeah. I'm still just struggling to try to figure out like the two-finger algorithm and try to figure out. Yeah, struggling a lot here. But yeah, I'm still struggling. Yeah, I mean, I have no lead at this point, to be honest. I mean, I think one thing that I was still thinking about is also the prefix sums, or just like the idea that because I knew for this one that there's like prefix sum e where you could build on previous ones, and in this case, it would not be like it wouldn't be a sum. It would be like an XOR type thing where like you know, because it's binary, so, or whether you only care about whether it's odd or even, which makes it binary. So, so I was trying to do something like that, but I was also do two fingers as well. Mm. Yeah, I struggle a little bit. Okay, yeah, and I cut back and forth erasing it all the time. But or just like just seeing if I could rewrite it or need to rewrite it or whatever. But I mean, I keep on writing the same thing, so I'm not even inventing anything new at this point. But yeah, I mean, I think I don't have that much to say about this one. So I'm gonna skip a little bit ahead. So bear with me. I mean, the link will be below. What am I doing here? Just a little. I don't know. I'm missing something really obvious, maybe. Each music. I don't get it. Ah. Yeah. Yeah, I guess it's some sort of greedy, but I can't figure out what am I greedy on. There's 500,000, right? So you can't really do n square. There's, I mean, I'm thinking prefix sum and all that stuff, but okay. I think I have a dynamic programming, but now that's kind of dumb, maybe. I don't know. Back again. Yeah. So now I was like, okay, I think I finally hit on that. Like, I think right now I was like, okay, there is a thing where for AEIOU, you only care about I mean, at this point, I don't know if I formulated it exactly, but so given a parity of AEIOU and you only care whether AEIOU is in the current set, you only need to look up the first case where that shows up. Because the first case where that shows up um, is that means that uh, the current status minus the first case where that shows up, that is the everything inside will have even numbers of all the vowels. That's what I'm trying to do, and I forgot how to do removal of an array. And then I just have a lookup table, and then I hash the first time I seen that. And I think I could have done this in a cleverer way, but but yeah. And this is just changing a set into something that is joinable. in a deterministic way, and so that I could put in a lookup table, hash table, which if you use a frozen set or something like that, you could also do it that way. I think now that I think about it, but yeah, now I just keep track of the first. Yeah, I was still like kind of playing around with this idea in my head, but now that I was like, okay, this is the first index, because I think I was like, do I need the last index or all the indexes? I was like, no, you can actually do greed because you're trying to think the longest, so you only care about the first one. So then that's what I did here, and I did. I think this actually cost me a couple of minutes because I wrote best is equal to index minus first minus key instead of just calculating the best, which is you know. I think I also have another base case error where I don't start off with 0. So like, but after I solve those or fix those two things, then yeah, um, yeah, and then that's pretty much it. I mean, there's just some minor typos in getting that one, but yeah, but that's the contest. Hope you enjoy watching it as much as I did. But yeah, bye bye. Off by one somewhere. That was actually hard for me, but whew, at least I solved it at least. Hmm. That was kind of a dreadful thing. Not gonna be 99 just because, but hmm. But yeah, I mean, I think that was. I mean, it's one of those things where if you have a really off day and your off day is, top 100, hopefully. I don't know where I end up, and especially since they merge into China server or whatever. Um, yeah, it's gonna be maybe. Well, right now it's 94, but I have 10 minutes of penalty, so I have to wait for the penalty people to kick in or whatever. Plus the Chinese servers, I'm probably not gonna be top 100, but just kind of yeah. I mean, that was kind of a surprisingly hard contest for me, and it looks like on a look that like I'm not the only person that struggled on Q2, which is kind of okay. Um, but I think this is a contest where not being practiced kind of hurt me here. And maybe, and given that this is a 4-pointer, there probably is a more obvious answer that I haven't done or that I didn't see. But anyway, I did really well on that one. So yeah, um, let's kind of go through my solutions, and then maybe later we'll go see our other pure solutions. But I definitely also have two penalties that are well. This one I accept because I should have just. I mean, I knew that was n square. I just okay. I mean, I'll go over it one by one when I go over it. But increasing, decreasing string. This is just simulation, so I did this I think pretty quickly, 3 minutes. But I'm also like just in a unfamiliar thing. But yeah, it's just simulation. Just literally follow these step by step, and you're doing okay. And the kind of what you get from practice is just able to convert these steps to a code that is robust as quickly as possible, and that's what practice will get you. And what I did is I just count them down this way, and I put it in a map so that it's easier to iterate through so I don't have to kind of like the data structure for me anyway was a little bit trickier to do it if I just kept the original string. Though you could there may be other ways to do it. I mean, there are definitely other ways to do it, but I just did it this way, and I am probably not that efficient. But at worst, this is going to be 500 times 26, so it's not going to be an issue. Q2, I'll do them. Yeah, I mean, I'm going to have to kind of review this later because for a 4-pointer, I'm sure there's an easier solution. But look at the timing. I mean, there are a couple of really fast people like Advice. Maybe even 5-6 minutes is pretty fast. And yeah, but also some people also took a long time or just did it last. So like, I don't know. Maybe it's something that I don't know. We'll kind of take a look. But the way I did it is that and I kind of struggle a lot with this. And how I kind of thought about it was eventually I looked at the first instance of each parity of each of these AEIOUs. So that means that it's almost kind of like that classic dynamic programming problem where you take the prefix sum kind of, and then you kind of find a number of, or the longest or the number, or a max or whatever, depending on the problem, which they tell you. The like whatever that sums to the target, right? In this case, the target that you're summing into is basically matching exactly what you had before, so the equal parity. And because you only have 5 alphabet, that it's going to be 25th, 2 to the 5th, which is 32nd or 32 numbers. So that's only going to have 32 cases, and then I do some hashing things so that I could put in a key. Though I think you could just use a frozen set or something like that. Now that I think about it, I was just trying to get it done. And with greedy, you always want to take the first instance, so that's why I do this here, and oops, and then otherwise I take the best. But I mean, clearly it took me a long time. Like I don't know, I have to go back to the tapes to kind of see, but I took 17 minutes after the Q4, and I probably took like 5 minutes before that, so I took like 20 minutes on this problem by itself. So definitely not easy. But I mean, ultimately, I still got it. So there's some learning lessons there, and hopefully, after the contest, I will kind of see, what the deal is, to be frank, so that I could kind of see like what was the insight that I was missing, because clearly, or should be, maybe there's an easier one, or maybe this is it. I don't know, and I just didn't, because I thought, I don't know, maybe I think some of it is too meta as well. Is that I thought this would be like what I'm doing here, maybe like it's trickier than I would expect from a 4-pointer, but maybe I'm wrong. Longest zigzag path in a binary tree. So this is the one where I ate 5 minutes. I actually have to, because this contest I did things in a weird order, or at least I spent Q2, so I don't know how much I've done on this per se, but I knew how to do this really quickly. I didn't actually do it, but I knew how to do it, and I think I just mentally thought it was 5,000 instead of 50,000, so that kind of was the issue, at least for me, and that's why I did n square, and I was like, it's okay, and then I just spent a couple of minutes debugging this caching because I created the cache on every recursion in the way that I originally wrote it, so that was terrible. So eventually I end up Googling how to do, the LRU cache stuff, at least in Leetcode. Because if I had done that, I could just put it on the go function, and that's all you need, and that would make the function linear, because you only do each of these function all of one times if you cache it. But because I didn't cache it, it was n squared, and 50,000 was too slow, obviously. So I ate 5 minutes there. 5 minutes plus a good amount of time trying to debug the caching. So this is where it definitely bit me. Um, uh, yeah. And then the last one, maximum. I mean, I think I used the same concept as I did before. I think there's just a lot of. So I did this one relatively quick, 15 minutes, but I also just had a lot of silliness with LRU cache and recursion. I don't know. I think I was just a little slow, to be honest. Well, I was just slow in general, but I did it in 15 minutes, which I probably could have reduced to like 10 minutes without penalty in a good day. Because I made, I think when I was typing or when I was formulating it in my head, I knew something like this, but I didn't actually type it out by the time that I was coding because I was juggling the feasibility of this. But if you kind of think about how this gets formulated, each of these function is cacheable. So that makes each of these function happens only all one times and or amortized. So this makes everything O of n, which for 40,000 is fine, right? So I knew all that. I just had some silliness with no, I mean, I took some time because I forget. I had to debug this case where if you don't have a node left, then or like it's none, this would never be true. I think I should, yeah, I don't know. I needed to change how I formulated, well, to what I did here, I guess. Um, and then the only other thing I did was the recursion limit, uh, which which is kind of sad. I mean, it's okay. You live and you learn. I mean, I think I just didn't really think about it because so the reason why I don't know, it's a little whatever is that in Python, usually the default recursion limit is 1,000, um, but in I think maybe I'm wrong on this one. So double check for me if you can. But I feel like I've done this in the past where in Leetcode, it's more than 1,000, but clearly 40,000 is not good enough. And I don't know what the real reason is. I just kind of made something big just to see if it would give me issues, and then it worked. So that I'm just like, okay, let's just do it. But because I think it is more than 40,000 because each function could call like get max, so maybe it's like 80,000 or something like that. Uh, or each SPST can call like other stuff or something like that, right? Or yeah, because each PST can get max, so it's like 40,000 square. Well, sorry, 40,000 times two. So probably the max recursion depth is 80,000. But yeah, I just didn't expect it, and therefore, I mean, it is literally my first time running into this issue in Python on Leetcode, so I don't feel that bad about it. I mean, it's a learning thingy, right? Okay. But yeah, I mean, I think I legitimately had struggled a little bit with this contest. So I think that's okay. I think there's some learning things here. Q2 is really tricky. I'm going to see how I just spent the most time on it. Like, like, hmm. I mean, I also had 10 minutes of penalty even on the stuff that I didn't know. So that was not a clean contest for me. But yeah, I'm just trying to think. Like without this one, without Q2, I probably could have finished everything in 25 to 30 minutes, like a regular Q2, which is probably on par for what I would expect. I need to clean up these. Well, okay, this one it's a learning experience. That's fine. I'll keep that in mind next time, or maybe the time after that, because I don't know if I learned that quickly. The TLE, I misread it, and like in my mind, I knew that was cacheable. I just didn't do it. Um, and on Q4, I'm going to try to see where I can learn on the algorithm side. I clearly missed something obvious. But yeah, thanks for staying tuned. Hit the like button, show some support because this was a struggle, and ask me questions or whatever. And see you in the next contest, hopefully. Bye bye. Hey, everybody again. This is the code review portion. I haven't done it in a little while, but yeah, this one I clearly struggled a bit with. with this contest. So let's kind of see where I could have made improvement other than obvious. So the first one was just one. Let's see. Let's take a look. Okay. Oh yeah, I mean this basically. That's smart. I mean it's basically what I did, except for that. Um, hmm, yeah, except for that looks at the key every time and then from the counters and then join them that way and then delete them when they're not anymore. I mean that's smart. I dig it. Dig it. Yeah. Basically, I mean, it doesn't even have to do. It just looks at all the keys that are available and then it deletes them, or like it goes through them, delete them. But this is actually happens first. So that's, I mean, same logic, but clearly much faster, like 2 minutes or so. Uh, Same thing. Lakers did the same thing I did, even though there's some frustration here. Um, see if I erased it. Yeah, same idea. Really. Well, actually, this is cuter, but yeah, and he did it for the number of times that are in the string, so it doesn't even optimize there. Uh, um, yeah, same idea as me. I think so. Okay, so I think I feel confident that we all mostly did the same thing, even though I felt like I did it a little bit slow because 3 minutes were easy. I've been slightly faster than that recently. Maybe not here, but in theory. Um, what the heck? Q2. Okay, that's the lookup table one, and this is the same idea that I did, except I did it much faster. This is actually kind of cool too. Um, so that for each mask puts it in an array and then just takes the biggest element and minus the min element, which is essentially what I do, but in a much, I mean, did in 2 minutes or something like that. That's crazy. It took me half an hour or so. Uh, yeah, this is this is the same code as I did, except for the coding or the actual programming is much cleverer with kind of lookup table where I did this funky stuff, but it does the same thing in theory. And this is just a DP formulation of it, but the same thing really. Because if you, I mean, in Python, you just put a hash table, and but yeah, but this is just more explicit way of converting from a binary number or to like dimensions and so forth. Um, yeah, I'm not uh, same idea. So I'm really not seeing why. Not really seeing why this is that given as a 4 pointer because well, there are a good amount of people that finished like in the 3-4 minutes range, but also a lot of people who took a lot of time to solve it. Um, and these are like the top people, right? So I don't know. Uh, yeah, what to say? Hmm. I mean, I am very happy that I did solve it though, because it was something that I feel like while I'm doing it, at least when I ultimately did solve it, I was like, oh, that's kind of cute. Like there's something that feels newish to me. So, but yeah, that's cute. Oh, there's the tree where I just forgot. Oh, I didn't know how to memorize. What did I even Yeah, did basically what I was saying should do, that I should do. Um, yeah, and uses the base case a little bit better. But I mean, these are. I mean, you could easily put this in a couple of DFS like I did, um, but can argue the results. But I would also say that yeah. Let's see. It is maybe interesting. Actually, I don't know if I know how to read this one quite yet. Um, oh, I see. So it goes through the same thing at the same time, and just keeping track of the left and the right. That makes sense. The longest left and the longest right from the current node. Um, hmm. and then the globally answer is just the best that you can get. Uh, and then each node will get processed and then it gets bubbled up in a good way. Okay. And therefore, I mean, that's clearly a way smarter than what I did, which is, um, yeah, I mean, yeah, hmm. I guess it's the same logic, but yeah, I think so there is something that algorithmically I could have done better, for sure. Um, like, I mean, mine thing works, but I think that, yeah, hmm. But yeah, it just also, yeah, okay, hmm. That's kind of cool. Okay, and then the last, I mean, I spent about 12 minutes on this one, or 13 minutes with a penalty, so I definitely could still be a bit faster. Though I think like as I mentioned, I've spent a lot of time on the caching. I think I'm, in theory, I think on the timing, like in terms of programming speed, I think my speed for trees are pretty okay because I feel like I've Leetcode really favorite trees and I've done a lot of them. That said, I spent 15 minutes on this one. Why again? Uh, oh yeah, because of the recursion depth, the LRU cache a little bit, and also just this silliness with the BST, which I had a silly thing on. But people got it in 5-6 minutes. So let's see. Uh, it seems like the same thing with last time, where instead of caching, they just do it in the right way, so that they bubble up everything they need to know. Which I was thinking about it when I was looking at this problem, was that I was like, okay, I mean, clearly, if you start on the leaves, this is actually really easy in that you could bubble up everything you need to know and then make a decision every time. And that's what these things do, and I guess that's what the pre-order thing helps kind of thing where I did this kind of weird. Well, I mean, I also mm, like definitely my contest code isn't as clean as it needs to be, but I also just was like, well, I knew that this would run in time, so at least I knew it was linear, maybe not the stack length, but so, and I think I spent a couple of minutes on the stack length. So without that, I probably got in 10 minutes, which I think is an okay time for a hard. Um, like maybe on a good day I could be slightly faster, but like I don't think that's an expectation. That's like you got really lucky that day or something like that. Um, but yeah, even just without a little bit of postmortem, if I didn't get the two what you would call it, the two submission errors, then I would have been still top 100, so that would have been okay. And that's given that I spent a long time in Q2, which I think it seems like other people struggle with the other forms and not necessarily Q2 as much as I did, but I don't know. I feel good. Anyway, maybe I'll do the next contest, maybe not, I'm not sure, but thanks for the support. Click the like button, hit the whatever button, and we'll see you next time. Thank you. Bye bye.